The skies over Portland, Oregon in March 2021.
Look up! Hey!
Oh my God!
What the heck? What the heck?
Debris from a rocket crashing down to Earth. Most of it burned up in its descent, but not all of it.
Wow.
A fuel tank plunged onto a farm. The people up here in orbit face the danger of space debris every single day.
We seal all the doors to the space station, then we cross our fingers and hope for the best.
If space is cluttered up with junk, it could destroy the satellites we rely on every day.
Suddenly, space will be out of bounds. That's fact, not fiction. And if that happens, there won't be much left of our business model or our company.
Is satellite trash something we should all be worried about? Aerospace students at the Technical University of Darmstadt need to wait patiently, but soon they get a glimpse.
There's something there. Look, everyone.
Shortly after sunset is the best time to see satellites. They're still lit up by the sun, while it's already dark down on Earth.
We need to keep our eyes peeled.
Now's the best time. It's moving north.
There's another. 2.
Many satellites are visible today. And Holger Krag from the European Space Agency, or ESA, can even identify which one is which.
That could have been a Starlink satellite.
Starlink promises to provide high-speed internet from space. The satellites belong to Elon Musk's aerospace empire. Soon after launching, they're bunched close together. Then ESA gets a lot of calls.
If you don't know what it is, you really do wonder. I get that.
The images recorded by astronomers are also increasingly crisscrossed by satellites. Starlink alone plans to launch 30,000 satellites. Other companies are also planning similar mega constellations.
We can see 6,000 stars with the naked eye. It could be that one day we can see more moving satellites than stars. Our skies will be full of motion rather than stillness. That's a radical change.
A new era has begun, the industrialization of space. And that generates all kinds of waste. At the ESA Satellite Control Center, Holger Krag can monitor what will crash down to Earth in the coming weeks, like rocket boosters or the debris from satellites, some of which have been in orbit for decades. And not everything burns up when it re-enters the Earth's atmosphere.
We tend to use titanium stainless steel, in fuel tanks especially, because they need to withstand immense pressure, or in engine nozzles, which must withstand heat. Because these materials are very heat resistant, it's a problem on re-entry.
Some 30,000 tons of space debris have re-entered the Earth's atmosphere in the last 60 years. No one has ever been struck and died. A lot ends up falling into the ocean.
The probability that you or I will be hit by one of these objects during our lifetime is smaller than the odds of being struck by lightning twice. And yet you just can't dismiss it. There are such people. I've heard of a person who's been struck by lightning 6 times. So you can look at probabilities either way.
However, it's clear that debris poses the biggest danger in space. And that danger grows with every additional satellite. The busier it gets in space, the more likely accidents are to happen. Debris from satellites result in new collisions, sparking a chain reaction, with consequences for us back on Earth. Take, for example, the European navigation system Galileo. It uses 24 satellites. To be able to pinpoint your location, a sat-nav needs to have contact with several of them. If one satellite fails, others take over. But if several are knocked out, things get less precise. As space fills up with debris, we're at risk of losing the tech we now rely on.
If you look at your smartphone, 40% of the apps on it have something to do with services provided from space, including navigation systems, weather forecasts, phone calls, and in the end, we'll perhaps even have internet from space. All of that is at risk if we do not sufficiently protect our infrastructure in space.
About 2/3 of space debris circles around the Earth in low orbit, including tens of thousands of big objects and millions of smaller pieces. And it's at this same altitude that's easier and cheaper for companies to reach.
Should be good. It's well aligned.
Walter Ballheimer and his colleague Michael Tolstoy are about to send a new satellite into orbit. They belong to the first generation of space entrepreneurs. The sector calls itself New Space. The satellites Ballheimer manufactures at German Orbital Systems are called CubeSats because of their shape. They're small and inexpensive to produce. They use the same microchips and aerials as automakers. These days, even a medium-sized business can afford to have its own nano-satellites in orbit to test technology or to transfer data.
Space is a bit like the Wild West in the way it's being handled. There are no laws. Whoever comes first stakes a claim, plants a flag, and that's it. Of course, it can't carry on like that.
The cheapest way of launching a satellite is in what is called a satellite separation system, like the one being developed by Michael Tolstoy. The CubeSats can be stacked up like tiny freight containers. All they need now is a lift, given that the cost of a rocket can quickly soar to 60 million euros.
Of course, you can't afford that if you've only just scraped together the funds for a small satellite like this. That's why it's good that the main satellite on here, that can be a telecommunications satellite or something big like Earth observation, has in effect already paid for the rocket.
The nanosatellites essentially hitch a ride into space. A few months later, Walter Ballheimer is on his way to the United States. He's going to deliver a number of small satellites for launch into space. He and his colleagues filmed themselves. Ballheimer has followed in the footsteps of his father, who helped build the Soyuz spacecraft in Russia. Back then, space agencies dominated the scene. Nowadays, one company in particular is setting the pace: SpaceX.
Crenshaw Boulevard, then turn right onto Rocket Road.
With SpaceX, multi-billionaire Elon Musk has built a business out of space missions. Among his customers are NASA and ESA. SpaceX even takes their astronauts into space these days.
I couldn't film inside the building. Of course, everything is top secret and off limits. And I think that the Americans might be less amused, or at least as equally unamused as the Russians, if you don't stick to the rules.
SpaceX is trying to make space travel more affordable. Cutting down on waste is part of that. Ballheimer and his colleagues stop by Cape Canaveral to check out a technological innovation from SpaceX. The booster takes the rocket on the first 100 kilometers of its journey. In the past, it would have been consigned to the trash heap after. But now, after about 8 minutes...
Oh, yeah, whoa!
The booster lands back on Earth.
Stage 1, London leg deploy.
SpaceX had to invest a lot of money to achieve that, and some established aerospace companies doubt whether that investment will ever really pay off.
They don't believe that in reusability, recovery of boosters, but you can see it works.
Yeah, it works, it works. And the Russians also said, like, when SpaceX said we will recover the booster, we just will build cheaper rockets.
But as space slowly fills up with debris, everyone will be affected. Back in Berlin, There's no international law for disposing of satellites, just an agreement that they will be brought back down to Earth no more than 25 years after ceasing operation. But fewer than half actually return using their remaining fuel.
That requires a cooperative satellite, a satellite that still responds to my commands, that still works. That makes it difficult for companies, the operators, to say, okay, even though it still functions, I'm going to get rid of it now. In most cases, the satellite is no longer responding. It isn't possible to communicate with it, or it's just tumbling around somewhere out of control. Then the only way to get rid of it is to wait until it burns up in the atmosphere.
And that takes time. Which is why here on the coast of the Netherlands, scientists are studying how to deorbit out-of-service satellites faster. This is where ESA's Technology Center is located. Here, researchers simulate space on Earth. They replicate the conditions in orbit, extreme radiation, and wildly fluctuating temperatures. Engineer Daniel Stelzel works at HPS, a Munich-based company. He's here to make the most of ESA's testing facilities. He and his colleagues have traveled to the Netherlands to try out a new technology intended to help tidy up space. ESA's Tiziana Cardone co-designed the device. Its purpose is to ensure satellites do not spend decades floating around as debris after spending just a few years in service. The small box contains technology that could bring decommissioned satellites back to Earth more quickly.
They come down eventually, but we need to speed that up. We're launching more and more and bringing down too few. It's getting ever more crowded. At some point, it'll be too congested and dangerous, so we need to act now.
The small box is fitted to a satellite before its launch. Once the satellite is ready for retirement, a small sail is unfurled from the box that increases its atmospheric drag, slowing it down and pushing it out of orbit. As it re-enters the Earth's atmosphere, it burns up. It's an effective way of getting rid of satellites in low orbit, where there are atmospheric remnants. It takes a maximum of 2 years for the satellite with the sail to fall down. Whether the sail unfurls at the right time hinges on Leonard Hoffmann's folding tech.
It's the first project I've been fully involved in, and many of my ideas have been incorporated, so it's really something special.
Development began at ESA. Engineer Tiziana Cardone invested a lot of work and passion into the project over the last few years, along with the company HPS. Now it's ready. The sail can rest on board the satellite for years in space, and then unfurl on command.
This system seems to work very well. But it would of course be a dream come true for me if everyone could see that.
And for everyone to see it, it must be launched into space. Today's the big day. In HPS in Munich, everyone is gathered in the company's production hall. Sometimes, staff get together here to watch soccer. Today they hope to see a successful launch. Daniel Stelzel's sail is inside now, in the top section of the SpaceX rocket, attached to one of the 88 nanosatellites. For Leonard Hoffmann, this is the first chance he'll watch one of his developments being sent into orbit. 11 minutes to countdown.
We're talking about more than 50,000 satellites from the US alone. And if we see the danger of these satellites colliding up there, and we can help bring them down earlier, I wouldn't want someone else to get this business.
There's no popcorn.
The final preparations are underway in Cape Canaveral.
5 minutes. 5 minutes.
But then suddenly the SpaceX transmission freezes.
Mine's working.
30 seconds to go.
We're just about 20 seconds away from liftoff.
It's 10, 9.
Hold, hold, hold.
Ah, no.
And we did hear the call to hold.
They stopped at 11 seconds from liftoff, and now we have to wait 15 minutes.
And then suddenly, the live transmission ends.
For today, that's going to do it for us.
They canceled it today. Yes?
No.
Really? Yeah. 10 Sekunden. Das ist gar nichts.
Just a few seconds before launch, an aircraft strayed into the safety zone around the rocket launch pad. Leonhard Hoffmann won't see his work debut in space today. Those who take the first leap in the new space industry can get rich. Latecomers lose out. But a new launch attempt is planned soon. What does it mean for the future of the aerospace sector if we can't get a handle on the problem of space debris? German astronaut Matthias Maurer has experienced the very real danger of space junk since November 2021. On board the International Space Station, the ISS, the risk to human life is greater than anywhere else.
Next up is European Space Agency astronaut Matthias Maurer.
Just 2 days after Maurer's arrival to the ISS, emergency strikes.
15 minutes to the next debris field pass.
SpaceX on console to have a conversation on Dragon to ground about forward actions if we do have a hit.
And Endurance Houston, yes.
The space debris hurtling towards the ISS was created by the Russian military after it destroyed one of its own satellites in a test. We spoke exclusively with Matthias Maurer about how the astronauts respond in such cases.
I go into the capsule with my crew. We seal all the doors in the space station, and then we cross our fingers and hope for the best. And if a piece of debris were to hit the space station, then we would still be able to fly away safely and land on Earth.
In this instance, the astronauts were able to leave the capsule after a while. But the trash remained too. A compact cloud of junk turned into a ring of debris. Because the gravitational pull is still strong so close to the Earth, the trash will probably gradually burn up in the atmosphere over the next 2 years. But between now and then, it could cross the space station's path several times. Even tiny fragments of debris are very dangerous in space because they collide at 40,000 kilometers per hour. The ISS is protected with multi-layer shields. A high-speed camera shows what happens when it takes a hit. The object is first broken up into smaller pieces by the external shield. Then the internal shield catches what's left. A robotic arm found evidence of thousands of such collisions on the outer hull of the ISS. The proliferation of space junk makes living and working on the outposts of humanity more and more dangerous.
This short-term thinking really makes me a bit sad. We all know, since we keep on finding trash in the world's oceans and our food chain, that we should protect and preserve our resources on a larger scale. And space is a resource.
Space agencies have set ambitious goals over the next few years. Another mission to the Moon, and then on to Mars. But if something doesn't change soon, our space ambitions might soon be crushed. We could be trapped on Earth by the junk above us. Stricter laws are not likely anytime soon, so it's down to the space industry to act responsibly. At the Space Tech Expo in Bremen, Germany, Walter Ballheimer wants to find buyers for his satellites, and he set up a new company.
No one's surprised if you're onto something new or working somewhere else. One day the company exists, then it's gone. That's normal.
Together with his new partners, he submitted a bid for an EU contract. The aim is to build up a satellite network to guarantee high-speed internet in Europe.
This is about many hundreds of satellites. What Starlink is for the US, but better and innovative, with data protection and everything that's so important in Europe. It's about implementing that in Europe.
Ernst Pfeiffer from HPS is also here. He's a spokesman for a working group for small to medium-sized aerospace enterprises in Germany. Everyone's curious about Ballheimer's plans.
You're making a constellation.
Yes, planning one.
You'll make one. You're leading the way. But what plans do you have to make your constellation disappear again?
We'd ensure it'd be deorbited 2 years after its operating life, at the latest. We're in talks about that.
Yes, 2 years is definitely possible with sails. We'd have to adapt the sail size to your satellites. How much do they weigh, roughly?
250, 300.
A sail area of 5 to 7 square meters, then.
The race is on to secure the best places in space. Starlink is the furthest along with its mega constellation. Several thousand of the 30,000 planned satellites are already in operation. Amazon is working on the Kuiper constellation. OneWeb has also started to launch satellites, as has the Chinese government, and a whole host of private companies. The more constellations in orbit, the more crucial it is that everyone's cleaning up after themselves.
You have to imagine, what happens when something like that goes bust after launching 600 satellites into space? Who's responsible for deorbiting? Who pays the personnel to issue the command? If it stops working, who intervenes?
Stakeholders agree. Europe needs its own constellation delivering high-speed internet and data.
If we don't have one, then we have a strong U.S. space sector on the one hand and a strong Asian space sector on the other. Should we count on always getting our data from these places?
Inconceivable for Europe not to have one.
How much of your constellation do you estimate will be sourced from Germany? 50%?
50 or more. You can find everything in Germany.
The German aerospace industry is growing. Some of the small startups from 5 years ago are now big players.
It's suddenly all within reach. You don't need multi-billionaire holdings behind you to build things that fly into space. You can actually build pretty gigantic things with relatively modest means and talent and passion. High tech. It's fantastic.
In the German space sector, many are hoping that the EU will give financial backing to sustainable solutions. At HPS, engineer Daniel Stelzel and the rest of the company dream of rolling out production of their satellite drag sails. But first, they need to send one to space.
The weather looks really good.
Unlike here.
Perhaps this time Leonhard Hoffmann will get to see the liftoff of his first major project. This is the second attempt to launch the rocket. In the production hall, there are live pictures again from Cape Canaveral.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ja, jetzt geht's los.
And liftoff.
Vehicles pitching downrange.
Yes.
It takes about an hour before the rocket reaches its intended orbit.
The MVAC engine on the second stage will form second engine start 1 and ignite that MVAC engine.
Through the live feed, everyone can closely follow how the 88 satellites are released one after the other.
Second ISI satellite, separation confirmed.
It's exciting. Unbelievable.
That's us at the bottom right.
Ion satellite carrier. Separation confirmed.
Ion 3, that was us. We're out there.
This was Ion, this was Ion.
Satellogic's new satellite team, the first ICE satellite from the exoport, NASA's Pathfinder, Planet IQ's GNOMES 2, the second ICE
And you're part of this.
Tieback 0211.
In 1 year's time, the drag sail should start pulling the satellite out of its orbit.
And the orbit's Ion satellite carrier. We were expecting
One last look as their product heads off into space. If all goes to plan, the people here hope it will result in major investment in their drag sails. In Berlin, Walter Ballheimer is also marking a special occasion. The EU has awarded the contract to him and his partners. As part of a study, they're now developing an independent European satellite network, initially as a computer simulation. But Ballheimer is convinced that he will be sending the first satellites into space in 2023. European industry is also calling for its own constellation to guarantee internet on Earth for self-driving vehicles, for example.
Automakers are one of the biggest employers in the EU, not just in Germany, but in France and other countries. It's hard to imagine that without satellite connectivity, they'd be able to compete with Tesla, which will obviously be connected to Starlink.
After all, both companies are part of Elon Musk's empire. Ballheimer and his team not only want to get into orbit as quickly as possible, they want to dispose of space clutter fast. Otherwise, there will be no future for new space.
This industry, yes, it's new. It's very promising. It could be a driver of economic growth. It could also generate wealth, in Germany too. We're still up at the forefront, but if we clutter up space, nobody will benefit.
ESA's Satellite Control Center in Darmstadt, Germany. Hundreds of collision warnings a day are now the norm for Holger Krag and his team. They know it can't go on like this.
So this is Sentinel 2A, so this is coming close as well. So when is it? Also on 3 days from now.
The Earth observation satellite Sentinel-1 could collide with a rocket booster if it remains on its current path. And debris from a Chinese satellite threatens to wipe out Sentinel-3. If things go on like this, the team will end up doing nothing but planning avoidance maneuvers. High time for something to be done.
There will always be nations that won't participate. But if the most important space nations, which generate the most traffic, come together, then that's half the battle.
In the end, the same principle applies to space as to protecting the climate. If individual nations don't play their part, everyone will face the consequences.